please also mute yourself. Yes, thank you. All right, we're here today, as you can see, in a new studio with two presenters, Ankit with me and myself, Gretchen. As you can see, this is a bit new for us. We really like it, but Frontend Lightning Talks is also always interesting to see and improve. We are both developers. We like to try new things out and build awesome stuff. So if there are any technical issues, please let us know, and improvements, we also would like to know that. I see our camera is also moving a bit, which is interesting, but we will try and fix that. That's no problem. There are a few moderators in the chat, so if you have any questions, just put them in there. And in the end, we can also have a cool hangout together and talk about the awesome presentations that we will have. So let's just start right away. As you can see, our meetup just got 1,000 members, so that's awesome. So yeah, how small applause. We keep on growing, and we really like it that you guys are enjoying the show as well. But today, more importantly, the Frontend Lightning Talks, the deep dives. It's a bit of different concept. Usually we do 3 small talks, but now we have 2 deep dives, which we both are very interesting because we have 2 different speakers. Well, but before we go to the speakers, we have some winners of a giveaway. Via LinkedIn and Meetup, we did a giveaway between 1,000 members, and we have 2 winners, Marie Shergi and Victor Renkma. They both can contact us via the Meetup group or via LinkedIn. That's also fine. They won a cool prize, but don't be sad. Today there can be more prizes for you in there as well. We have some small questions and some coding stuff. Well, for today, meet the presenters. We have Mark van der Walle. He'll do a talk about how the fuck does the internet work. He's one of our own guys from Society, which is really awesome, and he will introduce himself later on. And we've Gaurav, a reactor of TypeScript, which will be very cool as well. So you see 2 different subjects. Normally we have one dedicated meetup for instance, last time, front-end architecture. You can rewatch that in the YouTube, of course. And now we have 2 completely different things. Although the internet, of course, has to do something with React and, well, TypeScript then. Well, we are from Society, as you can see on the banner here, but this meetup is purely for developers and by developers. What Society is, well, name a company and we probably work for it. It's also very cool that we are with a lot of front-enders, as well as here Ankit. We like to just talk about technology, and that's why we do this meetup. If you want to present one time, that's also possible. Feel free to contact us. But Society has a lot to offer within the community, and we are guys who are really fun and enthusiastic about sharing the knowledge and improving. Well, I said it, name a company, and we've probably worked for it or are still working for it. That's why it's so awesome. With more than 40 front-end developers, we are having a lot of experiences and sharing that as well with each other. Well, Ankit, my co-host, will now take over. So Ankit, go ahead.
For the today's timeline, we just had a warm welcome from Christian, and after this, right just now, we have 2 topics. How the fuck does the internet work, starting just now, and then we'll have a small break. But before that, let's welcome Mark. And Mark, the stage is yours.
All right, let me share my screen. Well, hopefully everything is visible. I'll move that one way.
Go ahead, Mark, and give a big round of applause for Mark.
All right. Hey, so I'm going to talk about how the fuck the internet work, and let's talk about 2 seconds about the word fuck. You can just say it. We're not Americans. We are mainly taken to British English, which is fine to say the word. So what I'm going to talk about today is something that is very, well, important, I think, for most developers, but they probably don't know how it works mainly. And they probably know little about it, but I also think it's very crucial to our work to make things better, to understand better where things go wrong. So, but let me first introduce myself. I'm Mark van Walle. I'm a software architect at Society. Been doing that for some time now. Been also working in IT for quite a bit longer than that. Been doing this for 15 plus years. And I'm a Java backend developer also. So I don't do that much frontend, but yes, sometimes I do. Even I do stuff with frontend. But that's not important for today. I also work for many clients that Society works for, but mainly I live in the north. I'm broadcasting this from our Groningen office. But let's dive into what we're actually going to talk about today. So how does the internet work? And for many people, my parents for a very long time, until I explained a bit how does it work, well, not as deep as I'm going to do it for you today, but for many people, this is the internet. They go to their browser, probably Chrome or Internet Explorer, and they open it up and it starts perhaps at this page as their starting page. And that for them is the internet. It starts at Google. I've seen my parents actually enter the website that they want to visit in the search bar. Yeah, it does work. That's how Google works, but yeah, that's not really how the internet works. And it's also only part of what the internet is. And the internet was started quite some time ago, even before I was born, which is 40 years ago. And the internet was started in America by the defense agency. That there was a research project, and they came up with a way to connect multiple computers together. And that's where the internet was originally started, in somewhere in the 1960s already. So the internet in itself, or the concept of the internet, is already very old. Now, one of the protocols that makes up the internet was invented somewhat later in 1973. And still, the thing that we're looking at right now, this interesting Google thing, well, Google came up way later, but the way we actually get to Google, that concept was only invented in 1989, which still is quite some time ago. I was 7 at the time. I didn't know anything about it. I was happily playing outside back then. So I already mentioned one thing. And one thing of the internet is protocols. There's protocols everywhere, and there's new ones coming up, well, not daily, but very, very often. And are they all part of the internet? It's perhaps a bit vague, but lots of them are part of what makes the internet work, or what allows you to search on Google, or what allows you to stream Netflix or Amazon Prime, or send emails, or actually use WhatsApp and things like that as well. This is all going across the internet, this enormous beast of technology that we have created over the past decades. That's, well, you can't think of not having the internet anymore. Say, for example, the internet would disappear tomorrow, we would all be very lost and we would not be able to do our work. So protocols, and there's many. And there's IMAP, and there's TLS and ARP, and well, I can continue doing this for the rest of the evening, but I won't. There's many, many more, and some of these you might actually have heard of. HTTP perhaps in the top right. I see some DNS, but much of these you probably never heard of, and there's many protocols that I don't know either, and that doesn't matter. But it's good to have something of a foundation knowledge as a developer, as a front-end developer, but also as a back-end developer, to know what happens when you build stuff that goes across the internet. So what is the internet? And in a sense, in a very, very general sense, the internet is just a bunch of networks. So networks not of people, but of systems. My computer, my phone, the Wi-Fi access point, or perhaps my TV, or for some people even their fridge. They're all connected to a network, and all those networks are connected to each other. But how does that work? Well, I have to go back in time, unfortunately. And when I started out with networks, I started connecting two computers together. And that was already very hard to do back then. It was in the start of the, well, not roughly halfway the 90s. So let's say it's 1995. And we tried to connect two computers to actually do multiplayer gaming. The internet already existed with dial-up modems, so the things that make a lot of noise. But that's not how I started out, fortunately, because that was way too slow. We tried to play the original Command & Conquer or the original Duke Nukem against each other over the network. So how did we do that? We really needed something to make that happen. And we had things like this. This is a coax cable. And back then, you didn't have these nice clicky things or Wi-Fi. It didn't exist back then. And you had a cable. And to get that into your computer, you needed first one of these. So the cable goes to one of the ends of the T. That's actually a T connector. And the other one went in your computer. But if you tried this like this, so you had two of these T thingies and a cable between them, then it didn't work. It's like, what? So you needed actually to complete the loop, and you really needed something that was called a terminator. And back then we had a network, which was not actually using the protocol that's used today for the internet, but something slightly different. Mentioning protocols of the internet or of networking can be arranged in a lot of layers. Layers is something that's very common in software engineering and architecture, but also in infrastructure and networking. So how does that look? You have the OC model, and most of us probably will be somewhere in the top two, working there, making a connection to somewhere else, or something is connecting to us. So probably something HTTP. We might do something with presentation, so the data layer, presentation layer, so perhaps a JSON object from your API, but also the content of your CSS file or your JavaScript file or your HTML, or well, now with all the complex things that are happening on the front end, at least for me it's complex, way more complex than backend for me. So everything goes over a network, and there's many layers in the bottom, and in the bottom you have the actual physical layer, which is your device, which is the cables, which is the Wi-Fi router, and so on and so on. Let me show you some simple examples, so why it's interesting or perhaps important to know how the internet works, and especially I think for front-end development. We're going this side, and imagine that I'm trying to visit a website, and that website is hosted somewhere on a server. These days we have the cloud, so that's easy to have something in place. And this is already very simple, but so many things happen when I do this. and I will explain you what is going on. My computer makes a connection to a specific IP address, but how it does that and how it is actually relatively complex. And the reason why I want to show you something very simple website, you see, I am probably now connected to a server in Europe in the north. I think this one is actually in somewhere in Dublin or whatever, might be in some other European country. But if I open up something probably very familiar to you, and I connect to this, then it mentions, okay, it takes this amount of time. So 200 and I'm being disconnected.
Oh, I see it. Everything is green. I don't think it's so from our side.
Yeah.
Do you hear me?
Yeah, I hear you,
Yeah.
but I think
It's
this
only
is
your screen sharing that stopped.
Oh.
Yeah.
Yeah, it's there.
It's back.
Okay.
Interesting.
Yeah, suddenly the screen share was gone. So
That's how the internet
that
works.
was interesting.
Well,
Right.
good luck, Mark. You're doing great.
All right, so I'm connecting to the north, and it takes about 250 milliseconds, and I can refresh this a few times, and it will probably, oh, that's interesting. It actually takes all, this is very interesting. Normally this does not happen, that it's constantly having the same response time. That's very stable. But what if I am not connecting to something that's in Europe? I'm based in Groningen right now, so that's relatively close by. You can also do the same thing, do something in the US, which is way across the water. And it takes actually not that much extra time, and I will explain later about why that is, but it takes somewhat longer. That makes it load a bit longer. While you can't see it, and you can't really see that it loads, that perhaps you see it slightly blinking. But imagine this is a somewhat longer HTML file, and it loads CSS, and it loads images, and it loads JavaScript, and everything, all these documents, all these files, it will take about 350 milliseconds, or perhaps even longer if you're getting it from Asia, where internet connections are far less stable. So that is something I think why knowing how this works is relatively important for a front-end developer, because it can really speed up your website if you can actually lower this. And there's a lot of ways to do that, but I'm not going to talk about that. So how does my request from my computer actually end up in the server in a data center and give me a response back? That is very interesting. And that is, you can actually play a game with that, because how would you, if you wanted to go somewhere, but you don't know how? And that is something, well, now we just pick our phones and use Google Maps or something else, and it tells you, oh, you need to go there. Well, the internet has something similar. So how do we get from A to B? Simply by navigating. We have a navigator. And how does the internet do that? My laptop is now connected to a Wi-Fi network, but that Wi-Fi network gives me, well, there's a protocol there, and that protocol tells me, okay, if you want to go somewhere, you have to first go to the router. It's the router inside the network, and that's the first hop. Well, the router, it's in the corporate network of Society, probably knows about another router, and perhaps another. It depends on how complex the network is. And at one point, it will leave the network of Society, but each point in between knows where to go next. And that might actually differ from day to day. And there's many ways that can be done. There's lots of protocols again involved, but in the basis, one computer knows where to go next for a specific IP address. And the first step is very simple. My laptop knows only to go to one point. And the more you get into the internet, it becomes a bit more complex. So that depends on where you want to go, if it goes left or right or up or down. And I can actually visualize that for not relatively, but I can actually show that to you. What would happen? And I can do that with a command, which is a traceroute. Now, we're going to the US, doesn't really matter. And this will actually, at some point, time out, because not every hop in between will allow to give responses, but you see a lot of IP addresses of hops in between, which are in between me and that server. And they will all have to send that request forward, but also back. So the response needs also to get back to me. So you can imagine that if things go wrong at one point, then it might be slower, or it might even break. So there's many things in between that can happen. I mentioned, now it starts probably to time out, can actually show you also if I do not use the -n, can actually that it's named, see that there's IP addresses, but now there's also Capgemini. It's probably going over London and perhaps some other countries and larger companies that are making up the network. Now I'm getting into Microsoft, where actually the server is on Azure. All right, and you see now here New York City. I mentioned that my computer knows where to go first, but how does that go on in the wider network? And that is something like this. I mentioned there is a network of networks, and like my computer knows where to go for the next hop, all these networks, you see them as AS, that's autonomous system. So we in the Netherlands have a few of those, but across the world there's many large networks that are constantly talking to each other via a protocol and telling, okay, for the IP addresses, this list of IP addresses, you need to go to me. Or and they, through a concept of a gossip protocol, they're sharing that across the entire network. So the one system knows that for IP addresses, it can go there, and it tells all its neighbors, and those neighbors tell each other. So that system constantly keeps itself updated. There is something interesting going on, actually, with this. If, for example, autonomous system B would start telling its neighbors, hey, for IP addresses that it doesn't own, you need to go for me. You can actually hijack traffic, internet traffic that's happened in the world, or through misconfiguration, stop advertising, as they call it, so stop telling the world where IP addresses are, and you can actually literally disappear from the internet. And that is what happened to Facebook last year, or perhaps the year before, I'm not sure anymore. Facebook, Instagram, WhatsApp was completely unreachable. And they were disappeared from the internet because nothing was actually telling the rest of the internet where to go. So the routes to Facebook were gone. So you can actually physically disappear from the internet. This system keeps itself in check. Hijacking traffic is becoming less common because there is security in place, but concepts of misconfiguration are still happening. Now, then I am talking about IP addresses and networking, but these are very simple IP addresses. If you look at this one, okay, I can't remember it constantly, but if you used it often enough, you will probably know it, like a phone number or perhaps your social security number. You might remember that. It's also a very long number, but if you use it often enough, then it's easy enough to remember. Well, this is an IP version 4 address. They are very much common still, but there is a newer version of that, and those IP addresses are 64 hexadecimal characters, which is way harder to remember, and there's also way more of those. So this might be the IP address of a website or something else, or Netflix ads or Facebook, but you're not, if you're using all these services, you're not constantly having to remember these. What you remember is facebook.com or society.nl or primevideo.com. And that's a domain name. And how does this relate to networks and IP addresses? Well, there is a very interesting system in place which just tells you, okay, where to go, an address book or something like that. And that's the domain name system. And what is the domain name system doing for you? Well, relatively easy again. Your computer knows about a server, a DNS server, and it can ask, if I have facebook.com, what's the IP address that belongs with that? What will your computer do? Ask that DNS server, and that DNS server might already know the answer, might already have it in place, but if it doesn't know, it has ways to get to that answer. There is about 20 servers in the world that they are calling root servers. And those servers know, for example, where to find the top level domains like .nl or .com or .co.uk or .info or .net. So they know where to find answers for the first part of the domain. And that's the .com or the .nl. So for .nl, it will know that there is about 8 servers in the world, so it knows the IP addresses of those, where to get answers for society.nl. So then those servers are asked, hey, what's the IP address for society.nl? And then you'll get an answer, hopefully. There is a sort of resolving tree, and society.nl only has 2 parts. But what if you had many parts in front of that? And just showed you in the trace route, and perhaps you saw many subparts, and it might be that it's going to resolve for a while. Fortunately, there is tons of caches in place for that. And that is mainly how, well, roughly how the internet works. You have networks, you have networks that connect to each other, that are constantly keeping each other up to date of where to go. Your computer knows where to go. And that's perhaps even more important, with all the caching in place, otherwise the internet would be way slower and well, way more unstable. It's very much performant. Well, these are just a few small things, so tips of the iceberg, but there is more to this. So below the water, you know about icebergs, there's way more. And what I find fascinating about the internet itself is that it's almost everywhere. And no one really owns it. It is something that we as humanity created. And it has no borders, not real borders. And there is obviously countries that are trying to restrict access and like the Great China Firewall, or in Iran where the traffic is very much restricted. But most of the world has quite much unrestricted access to all the information across the world. And all the countries are very much invested in keeping that in place, keeping that infrastructure in place, regardless of, well, if they like each other or if they are at war. And there is obviously disturbances, but I like the way that there is no one really owning the internet, and it's relatively much governed by benevolent organizations. Again, this is a bit of the tip of the iceberg, and there's way more that you can talk about for this. But I would like to give you is that try to find out how this all works and how this works for your situation. If you build backend microservices, or if you build front-end applications or perhaps mobile applications, they all probably connect either over a network or over a network of networks like the internet. And there can be many things that can go wrong. And so there's so many things that you can do to make it right. That's what I wanted to tell you. Is there any questions on that?
Yes, thank you, Mark. Big applause for him. Thanks, Mark. Amazing presentation. I always like that seeing something internet related, so really the fundamentals, which is interesting. And there is indeed a question. It's from Suas, and the question is as follows. That sounds like processing overkill. On every stage, a processor has to find something from a list of available nodes, IP addresses, and forward packet to it right now. Yep.
Yeah.
That's indeed.
Yeah, in basis, that is what it is. So those things are in memory. The big optimized routers that are in place, they have thousands, if not tens of thousands of routes. So they are probably prefixes. Okay, for this part of the IP address, you can go there. Your computer just knows relatively simple things about that. My computer probably knows to go to the next hop, and other hops know a bit more about that. And that network hardware is very much optimized for this. So it's not your standard laptop that can do a bit of computations, but they're really optimized with optimized operating systems just for networking. And fortunately, for a lot of things, there's caching in place, especially for DNS.
Nice.
Does that answer the question?
I think it answered the question indeed. And without caching, we would be in trouble, I guess.
Yeah.
Yeah, there's another question as well from Antoine. If you can reach an IP6 network if I'm on an IP4 network.
Oh, that's going to be, yeah, in a nutshell, yes. But it's hard. It's very complex. How can I answer this best? Technically, you can, but it really depends on your provider, and it really depends on how that's in place. I think it's more common now than years ago, where it was relatively impossible or very much complex, and they made improvements on that a lot. It is not easy for your home computer to not connect to a IPv6 server, because the version 4 IP addresses are almost run out. We don't have that much anymore. So yeah, technically it's possible, but yeah, it's very much complex.
Awesome. I think it also answers the question. And if they're for the front enders, of course, if there's one practical tip you should give them, what is it?
Well, latency is key. So if you can place your resources as close to the end user as possible, and well, don't have that much resources, so don't have 20,000 images that you have to load at once. Yeah, latency is one, and then the amount of requests. So if you have a website that needs to be visited both in the US and in Europe, there's a few things that you can do. Either place it on both ends and make some way that you can reach that, or use a content delivery network like Cloudflare or things like that. So latency is really key.
Yeah, awesome. Personally, I really like AWS for trying this stuff out because it's really easy to do and you have the free tier, so I would recommend it for everybody. There's still one more question, I guess. Let's see, from Martin as well. Two important parts of the internet are redundancy and proxying. Perhaps you want to talk a bit about that, how it fits in.
Yeah, so probably from most bigger networks, there's many routes out of that. So if one route fails, you can still go across another route. That's the redundancy part. So actually physical network cables at the bottom of the sea have been cut, and then it takes years to replace those. So if there would not be no redundancy, then large parts of the internet would suddenly be unreachable. So there's many cables, and there is also satellite, which is very much slow, but there's many ways to actually go across the internet. So that's the redundancy part. Then there is proxying. Well, there's two types of that, but most corporate networks companies have a proxy that caches a lot of responses. So sort of similar like a content delivery network, but then in your company. So if I go to, for example, the Facebook.com, well, that's not a good example because you're authenticated. But for example, a news website like nos.nl, if I go there and you go there as well, lots of the content and JavaScript and images can be cached at your corporate proxy, and then it's already quite a lot faster and it doesn't hit the NOS server as much. So again, caching.
The answer to it all, I guess. Thank you, Mark. One time, give it up some more applause for Mark.
Thanks, Mark. Thank you. So
You're
next on the timeline is a small break, but before that, we have a small feedback form for you guys. In that, it's a very small form. We don't ask any personal information, but we ask you to give some suggestions and some topic which you want to hear for the next time. I'll paste that in the chat, and meanwhile, you can have a small break for 5 minutes.
Yeah. So we'll be back in 5 minutes.
Exactly 5 minutes. Okay, it's 7:45. Are we all back?
Aye, aye, Captain.
Okay, so before starting the next topic, we have some quiz for you guys. And yes, of course, meanwhile, you must have filled in the feedback form. Yeah, so the quiz is you have to finish these 3 questions. Just put your answers in the chat, and whoever is the first one will win the prize from us.
Yeah, so you need to type indeed the 3 console logs.
Console logs.
Yeah, what will be the result of those? The first one will get an awesome prize. Need to get in contact with us. There we go. Well, I don't think it's that hard.
Yeah.
There's some prize at stake.
I don't see someone typing.
Well, maybe people don't know it. So, for example, you only need to say the type in the chat.
Yeah.
So, from the first variable, the type is. Oh, I will give
Dash,
you the
dash,
first
dash.
one, string, and the second variable, what type is that? And what is the third variable? What type is that as well? The first one who answered in the chat wins the prize.
Okay, Sean, string, string, string.
Aye, that's not correct, Sean.
Ooh.
Close one.
Close, very
2 out of
close.
3 is good.
You have to answer all the 3 in one go, Nasim.
String number string, we have one.
Siddharth Gogli, yes, you are right, absolutely correct. String number string. You'll get some gift hamper from us.
Yeah, just get in contact with us via Meetup.
Yeah.
And then we can give you the awesome prize. It's a cool gift card, so be ready for it. And for the rest of the guys, thanks for answering.
Enjoy. Thank you. So the next topic is
Yeah,
Gaurav, and he will talk through React with TypeScript. Gaurav, stage is all yours.
Thanks. Thanks, Ankit, and thanks, Christian. So can you hear me first of all?
Yeah.
Yes, sound clear.
Yeah, perfect, perfect. Quick raise of hands. Just want to check if everyone is back from the break. Just raise your hand. We'll do a head count. Okay. Seeing few people coming. All right, all right. Still a lot of people not back, it seems like. I'll give it a 10 seconds so that people come back. In the meanwhile, I'm just going to share my screen. So, all right, can you see my screen?
Yes, I do see.
Perfect. So yeah, thanks for raising hands. I think people are back. Let's get started. So, hello everyone. I'm going to talk about React with TypeScript. First of all, a bit about me. I'm Gaurav. I work as solution architect at Verifone. These are my trails on the internet. Feel free to ask questions and connect. So the topic is React with TypeScript. So when we start a React project, by default, we are hooked with the JavaScript part of it. Even the official create React command starts with JavaScript. While it's good for beginners because it provides less friction and less complexity of writing types. But if you want to scale something, you would need to have types, and that's where TypeScript comes in. Yeah, so I followed this course on Educative, and I got to know more about using the right way TypeScript with React. So I'm going to share my findings and my lessons with you all. So before we go deep dive into benefits, code snippets, and some Giphies, let me show you a demo why you should switch from your React in JavaScript to React with TypeScript. So I'm going to share my VS Code. Let me stop sharing this and share. All right, so you must be seeing my screen now. Can you see the editor here? Yeah.
Yes, we see it. Awesome colors.
Right. Yeah, so to differentiate between two different projects, I just gave it different shades. So on the right, you would see an app with TypeScript. On the left, you would see an app with JavaScript. So the left one is in magenta, right one is in green. So I have this very simple app. It is a very simple app. It has an index, it has an app.js, and it just renders a header, right? And the header has some props passed to it, actually. And the header here component consumes it and renders it. So if you see here, in app, we are passing pages, and then it's an array, and then we have a name here. It's a profile pages. Well, while let's say we want to consume this in our application, we just want to use it. There is no auto completion if you are just simply using JavaScript. There is no auto completion. There is no IntelliSense. If I type profile name, it's not going to give me error or anything. So yeah, you will get an error when you compile it. But the best way is that you use TypeScript in your React projects. So let me show the similar structure. This is exact same app. You have your index.html, which basically renders the app. Notice we have TSX because it's TypeScript file. So in here, you do the similar thing. You pass your props here, but you would notice that here we will get an auto completion. For example, I'm passing a lot of profiles and then I'm just rendering them. So I'm just welcoming all the users I would be passing in. So now let's say I want to find what is my property of props, right? So it's gonna show me profile, while in JavaScript we didn't see that, right? Now I want to see what is there in profile. We will see that there are two properties, pages and user. I can go to pages and then I can fill it out, right? So that's the beauty of it, that you get IntelliSense, you get auto completion, you get errors. For example, if I type profile name here, it will give me an error, right? So I have defined the prop type here, and it is passed here. So prop is of profile, and I have defined the type in a separate file. Profile has a user, it has pages, and page is just name string. And your user has a name, as simple as that. We can also refactor our code very easily. So for example, if I go back here and I go to my types, I can just rename the symbol here. I can call it page name. You will notice something will happen on the right. Actually, let's not do this. Let's change the user. So let's change the page name here, rename symbol. I'm going to do page. Right. So you would notice that this actually was automatically updated by default. I didn't have to do it. Imagine you have a complex project. You can do refactoring very easily in here. This is one of the benefit. Refactoring is easy. I can also rename here. You would see that this has changed here, right? So yeah, this was a short demo. I'm going to switch back to my slides. So let me go back. All right, yeah, feel free to ask questions if they pop up. I will be checking the chat time to time. So before we go, deep dive into TypeScript, let's see what benefit we just saw. We saw IntelliSense, type checking, we saw easy refactoring, right? So let's build the foundation, because I would be talking about how you can convert your existing React app to a React with TypeScript. So we are going to talk about practical. We're going to talk about your class components, your states. We're going to talk about action reducer and defining types on them. So we have basic types in TypeScript. These are the basic types. With the help of these, you can make complex types, nested types. These are pretty straightforward. We have more types, for example, date. We have other union types. We have generics. We will come to them in a while. So first of all, JavaScript is loosely typed. What does it mean? Let's understand what problem we are trying to tackle here. So here we define amount as a number, right? But then we reassign it to a string. If you do this in TypeScript, you should get an error. But if you do it in JavaScript, you would not get an error. So if you're a TypeScript person, this is probably your reaction seeing this code. Yeah, so JavaScript, there is no type checking. There is no way to declare types. There is no change. You can change the type in between. If you're a JavaScript fan, probably this is you sitting in a room full of fire. So TypeScript is just, just tip of iceberg. Like these features are just tip of icebergs. Once you start using it, you would be in total love with TypeScript. So back to the types. How do we define the types, right? So you can define in multiple ways. One is type annotation. The other is type interference. So you have A as number, so you can declare let A as a number, B as a string. So now if you assign A to a string, it's going to throw an error. As simple as that. While you can also let TypeScript inference the type of the object which is assigned. For example, let A is equal to 10. TypeScript is going to see that, hey, this is a number, so let's give it a type of number. You don't have to explicitly say that. That's where this comes handy. And then if you reassign it, then you would get an error. Yeah, this is an example here. For const, the type of a const is actually the literal type of that value. So for example, the type of C here is going to be small string, because you cannot reassign it. It won't be a string. It will be the literal type of this value. So it will be a string literal type. Also note that type checking is not done runtime, but on compile time. So you would see when you're writing your code, it's basically type checking. We can still use the types during compile time. We will see how we do that. So there are a lot of types in TypeScript. Simple one is never type. If your function just never returns, it's a never type, just a silly one. My favorite is unknown type. Actually, if you are converting your JavaScript code to TypeScript, you probably will be using unknown type a lot, because you probably initially don't want know everything, or you just want to get things done, and then you can start, converting types to that or assigning types to that. So unknown is a very nice type. First of all, it let you refactor your code base very easily. So you have const may be unknown, and now, well, it's an unknown. That means that it could be any of these types, right? So let's say you don't know the type, you can actually write an if condition and say, hey, if maybe is a Boolean, then do this modification on that. And in this block, you cannot reassign it to a string at all. It will throw an error like this. So that's beauty of unknown. You can actually do refactoring very easily. We'll see a good example of this in next slide. Yes, here. So for example, we are talking about predicate type. Predicate type is a return function which always gives you a Boolean, and you can use it to check the type of something. For example, in here, we are fetching the data. So let's start backward. This function is getting a person, and this calls this endpoint /people/1. And this data is going to return a person. But it's possible that this data might not return a person type, right? So it's possible, since you are consuming over internet, you are getting 503, you are getting 404 and whatnot, right? And if you do not have any type checking on this, this is going to break your application, right? So predicate type is basically a function, returns a Boolean, right? It makes sure that person is this is the Boolean value. It makes sure that there is an ID in the person. So it makes sure that what we are getting, let's say it's a 404. If there is no ID, it's gonna return you false. But if it has correct data, it's gonna return you true. And based on that value, you can actually return the person. And this way your application is not going to break. So that's one. We have a lot of other types, arrays, tuple, interfaces. We can create types of our own. For example, we can create union types. We can create our own mix of types by using interface. We can also do that. That's there. We have generic types. I would not go in details, but if you see a lot of type definition for your package, they are going to use a lot of generics. Yeah, it's a complex topic, so I'm just going to skip it for now. So far we saw the benefit of TypeScript. We saw how you can use what kind of types you can have in TypeScript, right? Let's put things to practical use. We are going to create a strongly typed function component props, right? We all pass props in our components. We are talking about function component, not a class component. We'll also come to that. There is different things you have to do. So hello world, let's start with the hello world, right? This is a prop, and this is in a TypeScript file. It's going to throw error because it does not allow any type. So we have enabled TypeScript and set a rule. So we have to define the type of this prop. We can see that it has a who property, right? So how we can just define this and get this error go away? It's as simple as that. You can actually define the prop in the function argument itself. So here we have prop, and then we are defining the type of it. It's an object with who as a string, right? Or further, you can actually make your own type called props, and then you can actually define it here, do some clever logic, deconstruct it, and then directly just use who property. So far, so good. Are people awake? All right.
So far, so good.
Cool. Let's carry on. Yeah, so you can actually do functional component way also this way. Yeah, this is recently functional component way of defining props. Let's move forward. You can have optional and default props also. For example, I have this prop. In here, I have defined message as optional. That means even if I don't pass message, it's not going to throw error. But I can also define a default prop. So if I don't pass it, then it's going to take how are you, right? We are still on hello world, so we are printing hello, your name, and the message in here. So we talked about defining props with optional and default props. You can actually have complex types also. For example, you have a who person, your name, you would have a name there, friend. It could be a Boolean, yes, no, and then address, right? Address could be optional, and you can define address at top, and then you can just have a complex data structure also. So just trying to remove some friction to let you easily migrate from JavaScript to TypeScript. Let's see an example of a rendered prop, right? We are going to render something. So for example, I have this code snippet. We have already defined things here, right? But you will notice that we have added render message. Render message is a function which returns an HTML, I would say span, right? It's an HTML element. So how would you define if something is returning an HTML? We have types for that actually in React itself. The way you would do is it's going to be basically react.react node. It's as simple as that. And if something, if there is some other definition here, let's say you just print a string, then yeah, it's going to throw an error. It's expecting a React node. Let's look at the state, right? We are going top to down. We are defining a function. We are going to talk about props. We're going to talk about states. So we have an example here, right? We are using useState here, but we have not defined the state of this. It's very simple to actually define the state of this. All you have to do is you have to use this syntax and then define. This basically defines the type of the state. So count is going to be a number. You can also do like this if you set null as initial state. Yes, let's talk about reducer. So we have a counter. This is a counter code. So the counter is going to have increment, decrement steps, right? And you would use a reducer action dispatch there. And for that, you need to define types for this. So first of all, you're going to define separate types for increment, decrement, and then you're going to make another type of action, which is union. It could be either increment or decrement, right? And then you're going to use it here in this way to define the types. You have state and actions. Now, when you dispatch, you would basically check the type here. If it's a type, then yeah, you would have an add button there. When it basically, yeah, this is where you would dispatch. You can actually add an extra type safety in here. For example, if someone dispatch an unknown type, let's say make it double or divide by 0, you can actually catch it. And you can catch it by having a default block. So if you have a default block, it would make sure the TypeScript before compiling is going to throw an error and say that you have not defined a case for divide by 0 case, right? So it's going to give you an error. TypeScript can do a lot of stuff with very there are a lot of tricks there. This is one of the trick I really like, that it makes sure that it never reaches there. Yeah, so let's take a break with the memes. I've talked a lot about these TypeScript and JavaScript bashing, but there is nothing against JavaScript. It's just that it gives you stress, right? This guy is 26-year-old and he's in total stress. Yeah, this is, yeah, your bug is going to grow up. I think, okay, yeah. Yeah, actually this is cut off, sorry. Okay, break over. let's see what else you can do. We can actually do strongly typed class component, right? We did a hello world example with function component, but we can actually just, if you are using class component, you can also expand it. The way you would have, earlier you were passing the type or the prop in the argument of the function, but now when you extend React component, you can just pass the type here, and rest is exactly same, nothing changes. Yeah, this is as simple, as straightforward as before one, right? Let's see. All right. Yeah, I'm gonna skip few slides. I need to be on time also, so we will come back to all these slides once I go to the end.
Yeah, so indeed, that's a good one. You have 3 minutes left, Gaurav. Just
yes. So that's why I was just checking slides, right? So yeah, you can actually do a lot of stuff. For example, you can define event handlers here. All you have to do is you have to use this type React change event and HTML input, right? There is a lot in here. You can define context. I have example of these. I will publish these slides online so you can have a look at them later on. But yeah, in the end, you basically define types for everything. That's there. You can use context like this. So the goal of the talk is to get you started. I gave you a few examples, try to remove some friction, right? But thing is, now how would you get started, right? Create React app has a default TypeScript flag. You can actually inbuilt TypeScript flag, I meant. So in here, you can actually just pass template as TypeScript, and it's gonna create your application, which was in JavaScript in React, sorry, in TypeScript. Yeah, it comes inbuilt with ESLint, which checks your TypeScript linting. There's a lot of, it comes inbuilt with Jest TypeScript. There's a lot of things there. You can do that. I showed the structure of the project before. You can also create your React with TypeScript manually, but it has a lot of steps. These steps actually, you have to add React TypeScript separately. You have to configure Babel, linting, Webpack, npm scripts. The best way is you start with this, and then you can eject if you want to customize your React application. That's the best way I have done before. I can quickly talk about, I can just show you, I have 1 more minute, so I'm just going to show what comes when you share your, when you use Create React app. So hopefully you can see my editor now. Yes.
Yes.
Yeah. Okay. Cool. So in here, if you use that command with Typescript, you would see that it comes with lot of inbuilt functionality. So for example, you would have testing configured totally in Typescript. You would have ESLint configured here. You can actually just use prettier with one command here, and it will be smooth, seamless here. But so this is the thing. The way you, or I would say the way your editor knows how to, which types to map to which is basically through these type definition. So each package has their own type definition. The best one is the node, which actually covers everything. And then you have for React, DOM, and Jest. And then, yeah, of course, you need TypeScript. These are few things. Apart from that, the structures will be exact same. If you have a TypeScript without a component, you would just use TS extension. If you have a component, you are going to use TSX. And Babel, Webpack is everything configured here. You are not able to see this right now because I have not ejected this. So back to the slides. That was it. I hope you liked the talk. Please feel free to ask questions now.
Thank you, Gaurav.
Thanks. Everyone.
Life without TypeScript would be very difficult, especially for the people who React.
Yes. Code reviews are much easier with TypeScript, especially, and understanding the code base is best part actually.
Yeah. Yeah. Before we take the questions, let's give a round of applause for Gaurav Sehrawat.
Thank you.
There are a few questions in the chat. I can read it through. Mark seems to be away, but I can read the question and you can just answer. Is there still a place for classes when working with React plus TypeScript, or would you just use types instead? The other Mark.
Yes. Classes, of course, has their own. So in TypeScript, classes work as interface actually, and it works in dual nature. So if you define your class, methods, functions, and everything, you don't need to define an interface. You can actually use the class as the type. And yeah, this is kind of dual nature, hidden dual nature in TypeScript of class. So yes, you would definitely go for that, in short.
Okay. Thank you. So the next Mark, should that not be the type inference?
Oh no. Yes, you're right. It's type inference. I had this typo. Yeah, my bad.
Nice. Martin has a question. So how is the community adopting TypeScript? Are the big third-party libraries implementing it too?
Right. So I was reading the survey on NPM, and nearly every project, I think the stat was 90% plus of the active project have shifted to TypeScript. So if you are going to use a package, NPM package, it's most likely that it will have a type associated with it. You can actually, yeah, and all the types are there in one big repository. So you can find all of them. So yeah, there is big adoption actually from everyone.
Okay, I don't see any more questions. Martin says that sounds good to hear. One more question. How do you feel useState is functioning when working with complex objects, arrays and objects?
Yeah. So I try to show an example of complex type. You would actually use the state in the same way. The only thing is that, yeah, you would have to destructure bit, but TypeScript can handle a lot of complexity. You can find a lot of tricks when you start using TypeScript. It can handle, yeah, I would say, unless you go really meta level, where you want to check the type at runtime, you can pretty much do everything during compile time.
Okay, Mark, I think that answers your question. Next is Naseem. Many times we find an ID everywhere. Should we define a type ID, string or number, and then reuse it everywhere?
Yes. Yeah, it depends if your ID is a UUID or string, right? It could be your string and probably not a number. So you would just use a string. If something is ID, I would yeah, use it as ID as you suggested. Nothing wrong there.
Yeah, in continuation to the question, does it work to apply this every time a param is commonly used?
Is it worth to apply this every time a param is commonly used?
Maybe Naseem, can you elaborate more on that?
Well, maybe we can take it offline and cover it later.
Yeah.
Yes.
Yeah, I would say it does not hurt to define types at all. If you are going with TypeScript, it would only help you in long run. So you might save few seconds by not defining a type in params, but it's going to help you a lot when you refactor code, when someone pushes dirty code without test or anything. So just define types everywhere. That's my suggestion. There is a comment called microtypes are very useful also in backend development as well. Yeah, just not in front end. Actually, we use TypeScript for backend also. I will definitely recommend it on front end and backend.
Then I would say thank you, Gaurav.
Thanks a lot. Thanks everyone for joining.
Yeah, thank you, Gaurav. And well, let's go to the last part of the Frontend Lighting Talks today. We have had two deep dives. This is the 5th of July, but we're still looking ahead for this year. We're only halfway there. So we have different subjects. As we talked about today, this is a completely new setting for us. The studio is new, the format is new. So please fill in the form and give us your opinion. If you like it, if you don't like it. There are also different speakers. For today, Mark and Gaurav. Both pretty awesome subjects, and our studio is here. We will try to improve on that as well with the microphone and laptop, but we are also just developers, no communication department or something like that, so we are doing our best. In the future, we will have another deep dive session just to try out the subject a bit more, and after that we have 3 months, actually, September, October, November, of cool new Frontend Lightning Talks, one of CSS accessibility and WCAG, and the other one will be the impact of UX on code and code and UX. So we will involve designers in that as well, because we often work with them, which is very important. Feel free to contact us if you want to present, if you have an ID, or just want to give your opinion. That was it for the Frontend Lightning Talks. If there are any questions, Mark and Gaurav will be here till, I think, 10 more minutes at least. You can unmute yourself, chat a bit, and then we will stop the recording. Thank you for coming, and I see you at the next Lightning Talks.
Thank you all.
Yeah, big applause indeed. Yeah.